All righty, let's get started. I'd like to thank everyone who's joining us today. Welcome to today's CNCF webinar, Best Practices for Running and Implementing Kubernetes. I'm Christy Tan, Marketing Communications Manager here at CNCF. I'll be moderating today's webinar. We would like to welcome our presenters, Kendall Miller, President at Fairwinds, and Robert Brennan, Director of Open Source at Fairwinds. A few housekeeping items before we get started. During the webinar, you are not able to talk as an attendee. There is a Q&A box at the bottom of your screen. Please feel free to drop your questions in there and we'll get to as many as we can at the end. This is an official webinar of the CNCF and as such is subject to the CNCF Code of Conduct. Please do not add anything to the chat or questions that would be in violation of that Code of Conduct. Basically, please be respectful of all your fellow participants and presenters. Please also note that the recording and slides will be posted later today to the CNCF webinars page at cncf.io/webinars. With that, I'll hand it over to Kendall and Robert to kick off today's presentation. Take it away.
All right, thanks, Christy. Well, welcome everyone. This is the Best Practices for Running and Implementing Kubernetes webinar. If you're here for something else, you're in the wrong place. Otherwise, thanks for joining us. By way of introduction, so I'm Kendall, I'm president at Fairwinds. I've been here a little over 5 years. We've been a Kubernetes company exclusively for over 4 years now, which is a little hard for me to wrap my head around. All we do is help companies succeed with Kubernetes. And so that's something we've been doing for a long, long time. We've learned lots of things the hard way and excited to be here to talk about some of this with all of you. Robert, if you want to introduce yourself.
Yes, I'm Robert Brennan. I'm Director of Open Source here at Fairwinds. I'm also the lead developer on Fairwinds Insights, which is a platform for auditing Kubernetes clusters for security, efficiency, and reliability issues.
And we'll talk a little bit more about, please, it says I'm muted now, but I'm not muted, am I? I'm confused why I got that. Please do ask questions throughout. We will answer questions at the end. If you are asking something that's relevant to what we're talking about at the time, we may answer that as we go as well, but please do feel free to drop questions as we go. By way of agenda, we're going to be talking about common considerations, common pitfalls when implementing Kubernetes, what things you need to know right out the gate so you don't mess up in the long term. Then best practices for running Kubernetes in production. That's going to cover efficiency, reliability, et cetera. And then we're going to get specifically into some security implications because Kubernetes is just a whole new paradigm for a lot of people. It's a big adjustment in terms of just even thinking about how do we run it, how do we secure it, et cetera. And then we will leave time at the end for Q&A. So that's the agenda, and let's go ahead and dive in. So considerations and common pitfalls when implementing Kubernetes. So this is a whole new world, Robert. People have been running servers for forever, and they're used to being able to walk across a server floor and flip a switch off, or maybe they've been in the cloud for a while and they're working with instances that they can treat like pets or whatever. But what are some of the things that are different about Kubernetes that people need to know before they even get started?
So yeah, I think that the thing that surprised me the most is just how different a way of thinking Kubernetes involves. I, before coming to Kubernetes, had a lot of experience with AWS and with cloud computing, and found that I really needed to change the way I thought in order to work with Kubernetes. There's a lot of great training material out there for folks that are new to Kubernetes, but I would say that one of the biggest issues is that there are so many different ways to set up a Kubernetes cluster. There are so many different add-ons that do roughly the same job. So it's important to do a lot of research before setting up a cluster for the first time. This is something that we've come across several times at Fairwinds, where we'll have clients that come to us and say, well, we've tried 2-3 times to set up our first cluster and make it into production. We failed each time because we hit some issue, some requirement that we had that we hadn't taken into account when we first started setting up our architecture. So doing lots of research at the outset before you actually start building things, I think, is very important.
Yeah, and I would add to that one of the difficulties with Kubernetes is it's such a buzzword that there is lots and lots and lots of information out there by people who have kicked the tires on Kubernetes, right? But somebody who has stood up a cluster on 3 Raspberry Pis in their basement and writes an article about how Kubernetes is great and how it's changing the world has a very different perspective than somebody who has run it at scale in a production environment with production workloads and configured it correctly to be able to handle that. So and it's difficult sometimes online to find the people who are actually authoritative in it. So be careful about where you go get your information, because you're going to need to do a lot of research, try to focus on places that make sense. And I would also say, everything about the world of Kubernetes is ephemeral. And that's ephemeral meaning short-lived. And that's a really, really different paradigm. It's been a point of pride for sysadmins for a long, long time. Oh, I've had this server with 17 years of uptime, and that kind of thing is just completely different in Kubernetes. Yes, the workloads themselves are ephemeral, but we would even encourage you to think of all the way down to the cluster level as completely ephemeral, that you need to be able to wipe the cluster away and stand it back up if it comes to that. So that's, I think, one of the biggest paradigm shifts. It's a little bit like shifting from Windows to Linux is what I like to compare it to. Once you get used to it, if you're a developer, Linux is this whole new world that's really quite pleasant comparatively. But if Windows is all you've ever used your whole life, it's a big adjustment to make that switch. Okay, well, so on to the next thing, at a high level, still getting started. Why Kubernetes instead of serverless or ECS or Heroku, Robert?
So yeah, I think you kind of started to touch on this. But it is sort of like Linux compared to the Microsoft of these things, where Kubernetes is an open source project. It's a very open framework and open ecosystem. Almost all the software add-ons that you'll install on top of Kubernetes are open source. So compared to, say, like an ECS or a Heroku, which is a proprietary platform, you really don't have as much possibility for lock-in into Kubernetes. Kubernetes can run on any of the major clouds. You can run it on premise. So I think that's one of the big things for me, is that it's not, you're not locked into a particular way of doing things or to a particular service provider. The other big thing is that it's just incredibly flexible, far more flexible than, say, serverless or ECS or Heroku. In each of those frameworks, they have a very particular way of doing things, a particular way of setting up your application. They're going to restrict you to, say, particular operating systems. They'll want you to set up network traffic in very particular ways, whereas Kubernetes is really meant to be everything to everyone. It's a remarkably flexible framework. And there are so many add-ons out there that will allow you to basically get Kubernetes to you can implement serverless on top of Kubernetes. You can implement a Heroku-like platform on top of Kubernetes. So it's flexible enough to do all the things that any of these other frameworks could do.
Yeah, and I think one of the differences is, if somebody's going to choose ECS, probably their entire stack's going to be built on top of ECS. If someone's going to choose Heroku, that's going to be the entire stack. Serverless often plays a piece, and a lot of companies will run, primarily in Kubernetes and a few workloads on a serverless framework, or serverless on top of Kubernetes, like Robert's mentioning. I think I really like a quote that Kelsey Hightower said once. He said, everybody in the world wants a PaaS, a platform as a service. They just want the PaaS that they built themselves. And right now, Kubernetes is the closest that we have to a PaaS framework. It's the foundation. It's not a PaaS itself because it requires tremendous configuration. But with the right configuration sorted the right way, it feels like a PaaS that's customized for your needs. And it's really the framework for getting you there. And people are raving about Kubernetes all the time. Online, you see lots of buzz. There's reason for it. Can you use it wrong? Yes. Is it difficult if you're new to it? Yes. Once you get used to it, is it amazing? Yes, it's worth the hype. And that's part of it. So next, Robert, I'm an executive at a company, and I would like to throw some Kubernetes on top of what we have. Will that get us to a DevOps culture?
So there's definitely some internal, shifts in the way people interact with each other, the way teams are set up that are necessary for a DevOps culture. But like you say here, I think Kubernetes is able to amplify that transition. It makes it easy to establish patterns of working together and of communication between dev and ops that really allow developers to take more responsibility for how their applications run in production, take control over the deployment configuration around their applications. So Kubernetes is a great piece of a DevOps culture, but it's really one piece of the puzzle.
Yeah, yeah, I would add to that. I know companies that leveraging Kubernetes, and you can have DevOps culture without Kubernetes, you can have Kubernetes without DevOps culture. It can help, and one of the ways that it can help implement that is with Kubernetes. It's an API layer between the infrastructure and the engineer. And if you build things right with CICD patterns that input into that API layer so that Kubernetes handles things, the developer can have service ownership, which really helps DevOps culture, right? Like, if I know how to write code and deploy it and see it running in production and understand how it's running in production, and I have visibility into what's working, what's breaking, I can now own the things that I've shipped through to production. And that is DevOps culture, right? But a company with Kubernetes can set up all those things right and still require that ops sign off on things, that ops run everything, that ops get all the pagers, that, like you can still separate those things. Does the tool help? Yes. Is it really difficult to get to DevOps culture without the right tools? Yes, but it's not a sprinkle Kubernetes on it and everything will be great. Okay, well, so there's lots of problems related to this. It's scary, Robert. I think you've talked a little bit about go out and do the research. I mean, are there other things that people can do to avoid some of these common pitfalls when they get started?
Yeah, I think the big thing is to learn from best practices. The Kubernetes ecosystem has matured a lot over the last few years. There are some very well-established patterns like using infrastructure as code, established sets of add-ons for doing things like ingress or certificate management. So I would say sticking with some of those best practices is a good way to make sure that you don't run into any strange corner cases with Kubernetes. I would also suggest either finding folks who have lots of Kubernetes experience, who have run Kubernetes at scale, or finding a partner to help you on that journey. There are a lot of unknown unknowns when implementing Kubernetes, and so finding somebody who's been through these battles before and has the scars to prove it can be very helpful on your Kubernetes journey.
Yeah, that's great, and I think like the way I think about it is when we started, we were doing infrastructure services for a year before we were all focused on Kubernetes. And when we got started with Kubernetes, building the first production grade infrastructure, actually, we had a lot of experience. We were pretty good at it. But as soon as we started running into edge cases, there's the company who has 8 billion requests per second. Well, that breaks Kubernetes in new and unique ways. Running out of IP addresses with a client that we had at one point. There are battle wounds to get the hard way, or go into battle with somebody who already has them. And like Robert said, be that a partner or a hire that's experienced, you can avoid a lot of the problems by getting started that way. So let's get into some of the nitty gritty of this for best practices for running Kubernetes in production. Robert, on the reliability side, how do we reduce human error and avoid downtime? What are some things we can do for that?
So there's some great solutions in Kubernetes to avoid shooting yourself in the foot. One of the big things with Kubernetes is often we'll see companies will empower their developers to control the actual deployment configuration around their application. So setting things like memory limits and CPU limits, setting liveness and readiness probes so Kubernetes can tell if the application is running and healthy, things like that. And often the development team, if they're not used to specifying things like that, they'll either leave these things by the wayside and forget to specify things like resource requirements, or they'll make common mistakes like maybe over-permissioning their workloads to run as root, or do other things that they may not need, or have security permissions that they don't necessarily need. So one way to avoid this is to just implement everything as infrastructure as code, which makes sure that it's easy to track changes to your deployment configuration over time. And another great practice is to have some kind of auditing mechanism in place. We have a project called Polaris, which does some manual auditing of every single one of your workloads running in Kubernetes, as well as it can scan workloads that are being added to the cluster at the moment and reject them if they don't adhere to your own internal policies, say if they're trying to run as root or doing some other highly insecure thing.
And for clarity, Polaris is an open source project. You can go download that, install that in your cluster, without needing to get on the phone with us or pay somebody or anything. It's a open source project. So yeah, and I think like when it comes to infrastructure as code, there is a reason that people like pretty dashboards, and they can go in and they can click a few buttons and say, oh, I'm going to tweak this and check this. And the beauty of a dashboard too is different from a CLI or even writing it as code. You see maybe a drop-down list of the options you have, right? And that's really nice. And some of these tools actually do a really good job of taking whatever you implement in the dashboard and applying it in code in your infrastructure repo. Lean heavily towards those, because a number of those tools, you go in, you click a whole bunch of buttons, you set all the settings the way you want, you finally get it working, and this had better never, ever, ever go down because you have no idea what those settings are or how to repeat it. And maybe you even wrote down a big long list, but it's going to take you forever to go in and click that. And I feel like infrastructure as code is table stakes, and this should be obvious to people, but there are a lot of companies out there who don't even get that far. And it does help avoid downtime because you're not going in and clicking buttons to try to get things right. If something goes wrong, you have the code, you can deploy the code very quickly. It helps with auditability because the code is the documentation for the infrastructure. And talk a little bit about how infrastructure as code helps with disaster recovery, Robert.
Yes, so you touched on this before, Kendall, but we really like to treat everything as ephemeral in Kubernetes, including the cluster itself. So in an ideal world, if your cluster were to just disappear overnight, you should be able to recreate that cluster in a matter of minutes because you have everything that went into that cluster, from the core cluster configuration to all the workloads that are running inside of it, should be encoded somewhere in a Git repository, most likely. So it should just be a matter of kicking off your CICD process again, or maybe kubectl applying each of your resources individually in order to get your entire cluster recreated from scratch. So ideally, if you're using infrastructure as code, you should be able to go from 0 to cluster in a matter of minutes.
Okay. Yeah, that's helpful. It's have a DR plan. Even if your DR plan is we have all the code and we can start over again from scratch, which isn't the best DR plan, but is a DR plan. So have that in mind. Okay, well, on the topic of reliability, and we're talking everything is ephemeral. So talk about databases, because usually databases are not ephemeral. You don't want to just wipe them out and replace them with new data. So how do we think about running those? How does Fairwinds think about running those? I know a lot of companies come and say, hey, can we run our cluster in stateful sets?
Yeah, so this is a very frequent question that we get about how to run databases in Kubernetes. Kubernetes does provide a lot of abstractions like persistent volumes and stateful sets, which allow you to store persistent data in the cluster. And behind the scenes, it's typically using EBS, say in Amazon, in order to store that data. I would say this functionality is kind of, it's not as well supported in Kubernetes as we'd like. And it's something that we tend to push people away from. We would rather see them use, say, Amazon's RDS service in order to run their databases rather than putting it in the cluster, because like we've said before, everything in the cluster is meant to be ephemeral. And once you start storing persistent data in the cluster, that assumption falls out and is no longer the case. The ecosystem is definitely evolving, though. There's a new volume snapshot API, which is coming out of beta, I think in 1.17. It definitely will help with the database story in Kubernetes. There are some operators for certain databases like PostgreSQL that allow for high availability and automated backups. But again, it's all much more complicated and much more error prone than, say, running your database in RDS.
Yeah, and so, I mean, one of the questions we had come in asks, how feasible is it to run a H8 Kubernetes configuration across multiple availability zones on a cloud provider? My question is mainly around how you handle availability zone restrictions for persistent volumes provisioned on a specific availability zone. So a little bit to that question there, Robert, like You know, running clusters across availability zones, pretty easy because that's, you know, Kubernetes is designed to do that. It can handle the networking involved. Things can be ephemeral and handle that. You're not going to end up with all the race conditions that you do in terms of databases or persistent volumes. But answer the question specifically around persistent volumes across AZs. I mean, I think you touched on that already, but go specific.
Yeah, I mean, the short answer is it's very tricky. It's not something, it's not a common pattern. It's not a recommended pattern by the Kubernetes community. You'll find that there's support out there. There are some great PostgreSQL operators in particular, but it's a very tricky problem to solve.
Yeah, there's complexity here, and throwing it in a cloud provider's managed database service that's going to do this all for you, and you never have to worry about it, is just easy. Don't even think about anything else, unless you're running something like Cockroach and you're trying to do something new and fancy, and you have some specific business reason to do that. You know, in which case maybe you consider other alternatives. And I will say there are certain situations where we run things that are persistent in the cluster. Now, often there's some value of persistent where it can eventually go away if need be, or if it goes away, it's not the end of the world. But as a general rule, try to avoid that. Okay, let's talk about efficiency. How do I start thinking about building a CI/CD pipeline? Where do I start, Robert? What does that look like in Kubernetes? How is it different from previous kinds of infrastructure?
Yeah, so CI/CD is a very important part of Kubernetes. We do work with companies who early on in their journey will basically have a DevOps engineer manually applying their workload configuration to the cluster. Even if they're already using infrastructure as code, they'll, in order to deploy, they'll have an actual human being, run kubectl apply to get those resources, pushed into the cluster after they've been merged into master. That's reasonable when you're very early on in your journey, but it quickly becomes overwhelming for those engineers who are meant to do that, and it becomes harder to make sure that all those configurations have been successfully applied by a person. It makes it harder to ensure that what's in your cluster is actually reflected by what's on the master branch. So the two major ways we've seen of doing CI/CD with Kubernetes are basically one would be to push from your CI/CD provider into the cluster, and the other is to have the cluster pull from your Git repository into the cluster. There are positives and negatives to both. I think one good framework for doing the first way of doing things, pushing from CI/CD into the cluster, is a framework called Rocket Scripts, which we've developed internally. And then there's a framework called Flux, which will, I think, recently merged with Argo CD, and is much better for, it runs inside the cluster and will watch your Git repository and make sure that the cluster reflects exactly what's in the master branch of your Git repository. But having some automation there to make sure that what's checked in as code actually reflects what's running in the cluster is very important, especially when you've got multiple workloads running in you coming from multiple repositories. Becomes very overwhelming to try and keep that all up to date manually.
Yeah, I mean, it's one thing if you're, again, that person that's kicking the tires with Kubernetes on your Raspberry Pis in your basement. It's a whole other thing if you have hundreds of developers that want to be able to check in code all day long, and push to production without barriers. And if you don't have that process automated, you're going to run into problems very quickly. Okay, well then talk about instance groups and types and resource limits and requests. How do you get those right?
Yeah, so this is a very tricky question. It's something that because cost is generally top of mind for a lot of heads of DevOps or heads of engineering. This is really where you get leverage over cost. I would say in terms of picking instance types, you should think about if your workloads are very CPU heavy or very memory heavy, thinking about instance types that reflect that. If you have different types of workloads that maybe have different memory or CPU profiles, you can have several different instance types running in the same cluster, and you can specify the affinity for a particular workload to say, I want this workload to run on this type of instance and this workload to run on this type of instance. And that helps to make sure that you are sort of optimally bin packing your workloads onto the nodes so there's not so much wasted space inside those nodes.
And I mean, I would add to that, like, we recently spoke with a company that is treating Kubernetes like an old data center. They know what their peak capacity is, and so they have ramped up Kubernetes, scaled it to that big. They run every single process on the biggest instance type. They run, you know, as big of a cluster as they might possibly maximally need, and like, you're missing a ton of the advantages of Kubernetes by doing that. And getting these things tweaked and set right is a little difficult. I mean, I think even a lot of trial and error goes into it. A lot of companies will deploy a thing, see how it runs, and tweak accordingly, right? The vertical pod autoscaler is available inside Kubernetes that helps get some of that right, but we have an open source tool called Goldilocks that you can go look at as well, also in our Git repo. People just don't use the vertical pod autoscaler because it's complicated. And we've simplified it a little bit with this tool Goldilocks. Now, we also, in our commercial offering, have a more complicated logic that actually gives you insight into cost by workload. That's in Fairwinds Insights, if that's something that is relevant to you. At small scale, tweaking an instance so you save $5, $6 a month is probably not really worth a lot of your time. Don't spend a long time on it. At any kind of massive scale, having that slightly wrong can cost you tens of thousands of dollars very quickly. Anything more you want to say about that, Robert? I kind of interrupted you.
No, I would just say actually setting the requests and limits on a particular workload is tricky. You really want to monitor it in production. Maybe, you know, start by setting those requests and limits higher than you think you need, and watch exactly what your workload is using over time. Try and figure out what the the peak usage is, and sort of what its resting usage is, and set your requests and limits accordingly there. You also want to think about whether it's a workload that has a pretty consistent load, or if it's something that needs to spike over time. That'll help you figure out how far apart your requests and limits should be.
Yep. Okay, and then, I mean, talk a little bit about auto-scaling. I touched on this, but is there any reason not to be auto-scaling with Kubernetes?
So I would say for a reason not to auto-scale, you'll have much more consistent costs if you just say, this is what this is using all the time. But you're also going to be much more prone to, having outages. This is one thing that Kubernetes does really well, is scaling things up when you do get increased load to make sure that your end users don't experience downtime. There's three main dimensions to auto-scaling. One is at the cluster level. So if you have a workload that's trying to scale up and there's no more room in your actual set of nodes, if all the nodes are full, Kubernetes can add another node to your cluster using the cluster autoscaler, which is great if you experience any extra load, more load than you anticipated. We do recommend setting a limit to the cluster autoscaler, though, just to make sure that your cloud bill has a ceiling. There have been cases where folks had cluster autoscaler set up without a limit, or with a limit that was far too high, and they ended up scaling up and having a cloud bill that was 10x what they expected. The next dimension of autoscaling would be the horizontal pod autoscaler, which will scale a workload up to multiple different instances of that workload running, and Kubernetes will load balance between different instances of that workload. That's something that we pretty much recommend for every workload you have running in production. And then the last bit would be the vertical pod autoscaler, which you touched on, Kendall, which will automatically adjust the particular instances, requests, and limits to make sure it's getting the number of, the amount of CPU and memory that it actually needs to be doing its job. That's when we tend to shy away from, because it makes things a little less predictable, and presumably you do want some ceiling to, say, the amount of CPU or the amount of memory a particular application is using, because if there's a memory leak, say, vertical pod autoscaler may just keep feeding it memory when it really should have a ceiling of, say, 1 GB of memory.
Yeah, I think there are ways to do this poorly, and you need to be careful about that. But the big promise of cloud is that you don't have to own enough machines to match your Black Friday run, right? If you're an e-commerce site and you have one day a year where you do 100 times more business than normal, and have 100 times more traffic, you don't want to have to own a data center for 364 days a year. That's 100 times bigger than the rest of your load. And if you're going to be running in the cloud and you're going to be using Kubernetes, let your spend match your usage. It's amazing. It's one of the promises of cloud. And you know, don't be one of those companies that's running in Kubernetes and not leveraging autoscaling. It's one of the reasons to be using it. Okay, and then real quick, touch on spot instances, and then we'll get into the security side.
Yeah, so spot instances are a great way to save money. Basically, these are instances that are meant to be very ephemeral, where the cloud provider might pull them away from you at any time, and your cluster will have to find a different node type, say, in order to scale up. It's, like I said, a great way to save money because they're generally built much cheaper, sometimes at 90% off. The problem, though, is that they're so ephemeral that you can run into problems trying to scale your cluster up. If, say, you're running on all the same instance type, and suddenly they're all spot instances, and your cloud provider pulls them all away from you, you may have a period of time where you don't have any instances available, and your cluster will have to try and grab other node types, other instance types in order to scale up. There are great third-party tools like I think it's spot.io or spotinst that will try and manage some of this for you, because it is a really tricky problem. We tend to advise people to start small, start with a few spot instances, and see how that works out for you before making every single node a spot instance. But this is what Kubernetes is supposed to be good at, having extremely ephemeral nodes that can be ripped out at any time. So yeah, I think spot instance is a great way to save money.
Great. Let's hop into security. And I see there's lots of questions rolling in. Keep them coming. We will try to save enough time at the end to get to at least most of them. Okay, so security is different. Oh, and look at this. My text goes right off the slide here. I like it. Everything about a Kubernetes cluster is different. You're not managing individual servers. You're not watching individual servers like the old day where you need you actually have a physical pipe coming into your data center and you're managing everything. So it is a whole different world. We got to get into some of the specifics about it. Start with updates, upgrades, patching, making sure that you're up to date with all the things you're running in Kubernetes.
Yes, I'd say there's sort of three levels to keeping up to date. One is just keeping Kubernetes itself up to date, which is very important. We've seen a few companies that fall behind on one particular version. They decide the effort of getting up to the next version is too much, and very quickly they just start building up more and more technical debt around that older version using deprecated things. Their version falls out of support, and suddenly the add-ons they're using are out of support, etc. So it's important to constantly be putting in the effort to stay up on not necessarily the latest release of Kubernetes, but within the last 2 to 3 releases of Kubernetes. It can be difficult to stay up to date, especially when there are breaking changes. But in terms of just making sure that you're staying secure, being on one of the latest supported releases of Kubernetes is super important. And the second tier of upgrades, I would say, falls on your add-ons, so things that you're using for ingress, anything around certificate management, basically all these add-ons to make your cluster actually functional, any service mesh, stuff like that. You want to make sure that those always stay up to date. There's always new CVEs being announced, et cetera, new security patches getting pulled in. So keeping those up to date is super important. And then the last bit is making sure that the actual container images that you're using are up to date. So this is the base container image that you're building your applications on top of. There are tools out there to do container scanning, so to make sure that your running containers don't have any known vulnerabilities installed on them. But making sure those stay up to date as well is important, just to make sure you don't have any known vulnerabilities in your cluster, which would make it easy for an attacker to get inside.
Great. Yeah, and talk about automating TLS certificates in Kubernetes.
Yeah, so we recommend Cert Manager as a way of managing TLS certificates. It's a great way not to have to do this manually. Certificates get rotated very frequently. It works with providers.
It's another one of those, it sounds like table stakes, but there's a lot of companies out there who are not automating TLS certificate rotation. And when your site goes down because you have a certification that's out of date, it's just bad form. It's relatively easy to do. Okay, so then I'm a bank, Robert, or some other highly regulated industry, and I need to be very careful about who has access to what. So therefore, I have implemented role-based access controls. However, we have lots and lots of people, and we are a very large organization with lots and lots of different roles for various access. How do I manage role-based access control at scale?
Yeah, so RBAC is a very important thing to implement if you're at all security conscious. It makes sure that both the people and the workloads that are running in your cluster have access only to the things they need access to. There are some tools out there to help you manage RBAC, which are super helpful. One is an open source project that we provide called RBAC Manager that simplifies the syntax around creating RBAC. Another is Audit to RBAC, which basically looks at the Kubernetes logs to see who's accessing what and helps you create an RBAC profile that adheres to the principle of least privilege. So basically a profile that only gives that workload or that person access to the things that they're actually accessing. This is super important because it means that if an attacker were to say, find a vulnerable workload in your cluster, they might be able to take over that workload's container. They'll still only have access to the things that that workload had access to. If you weren't using RBAC, they'll be able to access anything inside your cluster. But if you have RBAC nicely pared down, they're not going to be able to access, say, secrets inside the cluster or access other workloads that are running in other namespaces.
Yep. How do we think about network policies?
So network policies are definitely a fairly advanced security feature. With security, there's always a trade-off between, developer velocity and being fully secure. A network policy is one of those things that, can push the needle a little bit away from developer velocity. So we don't typically implement network policy as part of our default Kubernetes implementation, but for companies that are very security conscious, network policy is a great way to tamp things down and make sure that, again, workloads only have access to the things that they need access to. There's kind of three levels to this. One is to make sure that a workload is only able to access other things in the cluster that it needs to. So if you've got multiple applications running in the cluster that don't depend on each other, making sure that they can't actually talk to each other. So again, if one of those workloads ends up getting compromised, an attacker can't reach out to other workloads inside the same cluster. And then network policy can help you prevent unauthorized ingress into your cluster. Say if it's an internal only workload, you can have an allow list of just internal IPs that can access that workload. And you can also tamp down on egress so that if an attacker were to get into your cluster, it would be harder for them to exfiltrate your data.
Great. And finally, I'm just racing through these, trying to get to some of the questions here too. But talk about workload identities, and then we do have a question specifically about secrets, but start there.
Yeah, so workload identity is a great way to, again, adhere to this principle of least privilege. In a typical AWS flow, you might have an EC2 instance that's running an application that needs to talk to an RDS instance that's also in the same AWS account. You could plumb through the credentials for that RDS instance into your EC2 instance and make that RDS instance basically publicly accessible. But that's a very insecure way of doing things because anybody could start, trying to brute force their way into your RDS instance. So Amazon provides a way to say, link that EC2 instance to that RDS instance using AWS APIs so that RDS instance is not publicly available, but that EC2 instance can automatically connect to the RDS instance. There's a way of doing this called workload identity in Kubernetes that works across all the major cloud providers, whether it's AWS or GCP or whoever else, that again allows you to tie a workload not to a particular node or a particular EC2 instance, or sorry, to tie a resource like a database, not to a particular node, but to a particular workload running inside the cluster. So rather than trying to plumb your database credentials into Kubernetes using secrets, you can basically just tell your cloud provider, I want this workload to be able to access this resource, and that your cloud provider will handle the secrets management under the hood.
And what is there a specific tool? So this question asks, how do you use the secret feature in Kubernetes? Is sealed secret the preferred approach? Is there another tool that we prefer? Do we use the cloud specific tools? What do you suggest?
Yeah, so again, you really want to be using infrastructure as code with Kubernetes, and that includes with secrets. The tricky thing there, though, is that you don't want to be checking secrets into a Git repository, because if anybody were to gain access to the Git repository, they have access to all your secrets. So what we typically advise our clients to do is to encrypt their secrets before checking them in as code into their Git repository. Sealed secret is one way of doing that. Mozilla also has a tool called SOPS, which is the one that we recommend. And again, basically these will encrypt your secrets inside your repository, and then your CICD process or your developers basically only need access to a particular private key that can be stored, say, in your cloud provider. That will help them decrypt all the secrets and then push them into the cluster. And that makes sure, again, that you can check all your secrets into your Git repository, make sure they're encoded as infrastructure as code without exposing those secrets.
Great. And we've got one more slide here on monitoring and alerting. You keep talking about infrastructure as code. Can monitoring be implemented as code?
Yes, so we use Terraform to implement both our Datadog rules and our PagerDuty rules as code in our code repositories. And it's a great idea to do this because it makes sure your monitor is repeatable. So if you were to set up a new cluster, you can just implement the exact same monitors in that cluster. It's a very important part of how we do things at Fairwinds, for sure.
And do we have a specific open source tool that helps with some of this, Robert?
Yeah, so if you're using Datadog, we have a tool called Astro that will help implement dynamic monitors as infrastructure as code. So it can create Datadog monitors on the fly. So rather than setting up a monitor each time you deploy a workload, you don't have to set up a monitor for each individual workload. You can set up basically a pattern for a monitor and say, every time I create a workload that matches this pattern, apply this monitor to it.
And it's worth saying this is a CNCF event. Prometheus tends to be the default monitoring tool used by the cloud native world. It is a CNCF project. We leverage Datadog for internal company reasons rather than anything else. But I need to make a plug for Prometheus while we're here. So talk about how monitoring plays into service ownership, or I can take this one if you want.
Yeah, go ahead.
So this is a little bit what I guess I touched on pretty early on in the does Kubernetes allow a DevOps culture? But when you're monitoring your infrastructure well and you're exposing those monitors to the developers, then developers can see how well their workloads are running in production. They can see when things are caught in an infinite loop and scaling wrong or crashing or whatever the problem is, and they can write code that then addresses that and deploy that back into production, and then watch the monitoring and see how it's changed, improved, et cetera. Service ownership is, a really key part to DevOps culture, and you have to have monitoring that's built well, that's exposed to engineers in order to get there. Finally, in Kubernetes, there's a lot of things the cluster is going to respond to for me. There's a pod goes down. I don't need to wake up and turn that machine off and on to see that it gets back to healthy. Kubernetes is going to do that for me. It's going to kill off a pod and bring up a new one. So there's going to be some alerts that aren't going to be actionable. Talk a little bit, Robert, about what should we be alerted on? What are some just high level? What kinds of things do you care to be alerted on? What kinds of things do you want to ignore because Kubernetes is taking care of it for us?
Yeah, this is always the big question with monitoring is. Basically, how noisy do you want to be? You want to make sure that you're noisy enough that you catch legitimate outages, you catch legitimate problems before they end up causing problems for your end users. But you don't want to be so noisy that your engineers are getting woken up at 4 a.m. every single night. So it's a great way to have high engineering turnover. So it's something that we constantly tune with each of our individual customers. There are certain things that we make sure that we alert on across customers, like say if a workload is failing to scale up when it needs to, if there are pods that are say stuck in pending status, that's something that we always want to be alerted on. There are other things like if a pod crashes, if it happens once, it's probably not a big deal. Kubernetes will just start up a new pod. If it's happening very frequently over and over and over again, the same workload is seeing the same pod crash over and over again, then that's something you want to get alerted on. So we typically start by basically alerting on all the things and then tuning the thresholds of those alerts over time, saying how many times does this need to occur in a particular 5-minute period or 1-hour period before we're actually worried about it. And then if there's something that, we're getting woken up for all the time that isn't really an alert, we'll continue to tune those thresholds over time. But we tend to say, let's err on the side of catching everything and getting woken up a little bit more often than we need to make sure that we never actually experience a legitimate outage.
Great. So the next section is for questions, and I'm going to go ahead and just start working through some of these. We're going to try to get to as many as we can. We may not get to all of them. So back to early on when we were talking about persistent volumes, can EFS be used for persistent volumes?
It can, yeah. There are at least a dozen or so different storage providers that have implemented the Kubernetes standard for doing volume storage. It's not, I wouldn't say it's easy, but it's possible to implement any other storage provider if you wanted to, have, say, an on-premise version using your own volume type. There are ways to implement the storage interface in order to get it working with pretty much any kind of storage provider. But there is an existing one for EFS.
Thanks. Next one is, what's your view on implementing services like AWS Fargate together with K8s? Have you implemented such configurations in production systems? And I'll start, and you can add on to this, Robert. I mean, the short of it is there's advantages to a lot of these systems, right? Fargate does a lot of the logic for you. And if you can throw a container at Fargate and have it handle everything for you, leverage Fargate. There's nice reasons for that, especially if you can afford it. I mean, a lot of the reasons people end up using Kubernetes is it's cheaper to figure out all the configuration yourself rather than to have Amazon doing it all on the back end. And there's definitely situations where it makes sense to have one thing running in one service and another thing running in another service. As for, can we suggest it? It's entirely based on like your workload needs. There's probably good reason with good configuration to just do it yourself in Kubernetes. If you don't need that, throw it to Fargate. I mean, it's the same thing I say about things like Heroku. Like if a PaaS works for you and you don't need the customization of your own personalized PaaS, just use the PaaS. It'll save you so much effort. It's just that at some size and scale, almost everyone outgrows a PaaS. Anything you want to add to that?
Yeah, I'll just reiterate that, there are good reasons to use Fargate, but we typically see, especially with these proprietary PaaS type systems, folks eventually outgrow them. Either they hit a certain scale where it's worth a little extra complexity to save a lot of money, or they'll outgrow. Heroku's when we see folks outgrowing pretty regularly. So staying away from proprietary systems and toward more open standards like Kubernetes tends to be a little better in the long run.
Great. And along the same lines, as far as how does serverless or AWS Fargate scale? I mean, there are limitations to the way some of these services scale. And one of the problems that, we have had people come to us for, a company that's running entirely serverless and wants to move into Kubernetes because they don't have as much control over the way it's scaling or how fast it scales or the cold start problems or whatever. There's lots of complexity there. If it works for you, use it. If you need more complexity, you need more configuration, you need it more customized for your needs, that's why people are using Kubernetes. There's another question here saying, yeah, I set up GitLab CICD with OpenStack Kubernetes. It took weeks to set up. I have good friends at GitLab. They will be devastated to hear that. They try to make it really, really, really easy to deploy into Kubernetes. Getting things right takes time. If you have good processes in place and you document it all as code, the next time you do it, hopefully it'll be very quick. Okay, here's an interesting one. Can you please spend some time discussing aspects of multi-tenancy or best practices for production clusters? For example, how do you separate out namespaces, RBAC, network traffic, isolation policies, et cetera? I think we got to some of that, but specifically as it relates to multi-tenancy, for those that don't understand multi-tenancy, I'll just give a high level, and Robert, you can correct me if I get this wrong. So single tenancy is, say, your Kubernetes cluster is, running one workload for primarily you or one customer. That would be single tenancy. Multi-tenancy is, say you have a SaaS application and you have 500 banks all using it. They need them to be isolated out, and you want it, you don't want to have 500 different clusters running, so you have one cluster running, and you've done a whole bunch of things to make this multi-tenant cluster secure in its own little enclaves. Did I get that right, first of all, Robert? And then anything you want to say about that?
Yeah, no, I think you got it right. And I think this this question touches on some of the big ways of dealing with multi-tenancy. Namespaces, I don't think we touched on in the presentation, but namespaces are a great way to keep things separated from one another. RBAC is very namespace aware, so you can create RBAC permissions that only apply to a particular namespace. We do see people just shove everything in the default namespace, and that tends to lead to problems. Kubernetes clusters are, designed for multi-tenant type applications. We do, however, see a lot of folks just out of sheer paranoia decide to spin up a individual cluster, either for every team in a different organization or for every tenant. That does help to just reduce the possibility that clusters start to step on one another's toes, but it's not necessary by any means. Kubernetes does provide the tools, like this person points out, between namespaces, RBAC, network policy, to have a good multi-tenant setup. But it all depends on your exact needs, how to leverage those tools.
Yeah, and there's another question here that says, do you recommend large multi-tenant? Let's see, where did that go? I'm scrolling through. Do you recommend larger multi-tenant clusters or smaller single-tenant clusters? There's so many levers in there. It's hard to give you a recommendation for what your specific needs are. I will say one thing to think about is if you're running Kubernetes, if you have so many clusters to manage so many single-tenant customers or so much single tenancy, you've basically created a cloud provider's Kubernetes, right? Like you've created GKE or EKS or what, that's what those are. They're huge Kubernetes clusters running lots and lots and lots of single tenant Kubernetes clusters. And don't go reinvent the wheel. There's ways to tweak it. Unless you need to reinvent the wheel, there are use cases. Yeah. Does enterprises running 2 clusters in production so that they can fail over in case one cluster has issues? Okay, so there's an enterprise running 2 clusters in production so that they can fail over if one has issues. What practice is followed as any cluster issues might impact a whole bunch of pods? That's a big complicated question, I'm not sure. It may be, in theory, detaching all those pods and plugging them into the new cluster versus spinning up new pods. I mean, I think the answer to this is however you decide for failover, if that's another cluster, if that's the ability to stand it back up really quickly, you should not be worried about a cluster going away and it impacting pods. You want to have pods that can come and go. Yes, there's going to be downtime if that happens, if all the pods turn off. But I don't know. Robert, do you have a way to address that? I'm not sure I'm getting to the heart of this question.
So this is a fairly typical disaster recovery setup where you just have a second cluster that's a mirror of your first cluster. So that if something awful happens, say to the core infrastructure of Kubernetes, your etcd store gets completely screwed up, you can switch some DNS settings and start directing traffic to that second cluster. That is a great way to do disaster recovery. I would say it's really a method of last resort. It should be something that if you have a particular application that's experiencing an outage, you shouldn't be falling back to your disaster recovery cluster. You should be using Kubernetes internals to figure out how to properly restart that application inside the existing cluster. But again, something can go wrong with the core Kubernetes infrastructure sometimes. So having that secondary cluster spun up is definitely helpful.
Okay. Gosh, there's a whole bunch here. With upstream Kubernetes catching on quite nicely, do we truly need OpenShift or PKS? Have you come to the right people to ask this question? There's advantages to having a distribution of Kubernetes, and the advantages like with a distribution of Linux. You know that there's support, you know when that support runs out, you know what that support looks like. I am of the opinion that Red Hat is very much riding the Linux distribution model into Kubernetes, when what people, I think, want in Kubernetes is best practices and support around the open source rather than support around a specific enterprise version. That's the market we serve, though, so I know that I'm biased. There are a lot of companies that have been long time Pivotal customers or Red Hat customers, and they just want to keep going using the same thing because they're comfortable with that service and they understand how it works. There's place for both. If you want Kubernetes best practices, come talk to us for upstream. And we are running out of time. Unfortunately, we didn't get to all the questions. We are happy to talk about some more of those another time. I do want to give a quick plug. If you want to know more, we have a white paper, Kubernetes Best Practices, at fairwinds.com. Click on resources, and that'll bring that up. It gets more deep into some of the specifics around security, efficiency, reliability, et cetera. We break it up in a similar way. It's a white paper that you can download, look at, digest slowly as you need. And then also finally, Robert mentioned at the beginning that the product that he oversees is Fairwinds Insights. We build and maintain infrastructure for lots and lots of companies, and we recognize that not everybody knows how to best leverage Kubernetes. And I believe everybody would be adopting Kubernetes if they believed they could do it securely, reliably, and efficiently. And this is a SaaS tool that tells you what you're doing right, what you're doing wrong, and importantly, how to fix it in most situations. We actually offer remediation steps. So whether you're a senior engineer or not, it's going to say, hey, this thing's wrong, and here's how to go fix it. And that's a big deal. So there's a free trial for that. That is a SaaS solution. Finally, if you want help with Kubernetes, however that is, we have tons of open source. Check out the Fairwinds GitHub. We have services to help do this for you. You can hire us. We will build and maintain the whole thing for you. It's all upstream Kubernetes. There is no vendor lock-in. And if you want to try one of these other things, we also have software solution, et cetera. But thank you, everyone, for making the time, and we really appreciate it. And Christy, with 2 minutes left, I'll turn it back over to you.
Awesome. Thank you so much, Kendall and Robert, for a great presentation. I know we have a lot of questions that weren't able to be answered during this time. Is there another way that they can connect with you, like via Twitter or anything that you might want to drop in the chat for folks?
Sure. So both Robert and I are available on Twitter. Here I will go back to the beginning of this that has our, if I can.
Yeah, I thought I saw it on one slide. Just wanted to make sure we show folks.
Yeah, so I'm blatant error, and well, Robert, you're listed there as Fairwinds Ops. Robert's also on Twitter. I don't know if you want to share your handle, Robert.
I think it's at rbren_dev.
Okay.
Awesome.
And you can also reach out to the Fairwinds Ops Twitter, and we are happy to answer questions.
Great. Awesome. Well, thanks again. That's all the time that we have for today. I'd like to thank everyone who joined us. A reminder that the webinar recording and slides will be online later today on the CNCF webinars page. We look forward to seeing you at a future CNCF webinar. Have a great day and stay safe. Thanks, everyone.